Thank you, Neeta, for that glorious introduction, and my absolute pleasure to be in front of you all. It's an emotional moment. 10 years of Grace Hopper. I still remember the first one. We were in the office and we just got pulled out saying, there is this conference happening. We got to go. We got to go. And it was about 600 people back then. It was small enough that a hall in Taj Vivanta on MG Road could fill, and to this, which is 10 times the size, it's a delight. And it's an absolute honor and privilege to be here speaking. Infrastructure. Just show of hands. How many of you actually work in the infrastructure space? Yay. Oh, this is great. This is great. So let me start with a story first, a personal story. My career started as a developer and it grew as a developer, into development, and I thought, that is the most glamorous it can get. Worked in the financial markets, so speed and risk and solving complex algorithms, creating payment waterfalls for investment banking and things like that. All that was very exciting. Till a point in about 10 years back or so, I took a few months off from my work and I decided to do nothing, to just go on a couple of months of sabbatical and focus on the other life that I was missing out on. And I get a call from a recruiter. The recruiter was calling from Goldman Sachs, and she was, pitching an infrastructure role to me. And I was in a great dilemma, right? So those of you who worked in the financial world would agree with me when I believe that, if Goldman Sachs calls, you respond, because that kind of is sort of an, the Google, or that would be the Google of computing, if you will. So I wanted to respond, but infrastructure, I said, I'm not a hardware engineer. That was the first thought that was going on in my mind. I'm not a hardware engineer. And infrastructure at that point meant boxes to me. The visuals that were going in my mind were boxes. Network routers, large servers, huge storage boxes and things like that. And of course, all of them fitted in even larger rooms called the data centers. So it started from there. And this is the thought that I had. Am I doing it right? Yeah. This is the thought this is exactly the thought that I had. But then, of course, it was Goldman Sachs, so I decided to make that conversation. And about 14 such conversations later, and 3 months later, I landed up a job in Goldman Sachs in the infrastructure space, running one of their largest transformation programs, and one of the most expensive programs that the infrastructure at Goldman Sachs at that point undertook. And that was to, do everything straight through. So whether it was any provisioning or any augmentation or any decommissioning or whatever have you, so anything that in the infrastructure world should be straight through, and that meant a lot of software writing underneath, right? You're not going to pick up boxes. And it did two things to me. One is it busted the myth that infrastructure is boring and infrastructure is all boxes. And second, it opened up my eyes to the world of opportunity in terms of, if you want to solve problems, if you are an inquisitive mind, if you want to apply software techniques, and if you think you are a great programmer, what else and what are the opportunities that are there? So two things that happened. And since then, and I'll tell you, there are some very, very, funny moments that I went through, and some nervous moments also as I did that role in an aggressive environment such as that. Some fundamental questions like what is SRDF, right? It started from there, and what is active and things like that. So that working in a real-time transaction processing areas and things like that. So it started from there, but trust me, as I went deep, I realized that a lot has changed. So you see this. On the left-hand side are your classic data centers. So, of course, there's a room full of people working on the infrastructure space. So you would know what data centers are. Data centers are, everything, think of it like a hub where all your applications, your network, your traffic, your voice, your whatever have you, it just goes there. Otherwise, you'll be writing code and deploying it on your desktops, right? But this is where it all sits across, whether you are on WhatsApp or whether you're on Facebook or whether you are writing code for your own self or whether it's the fabulous medical equipment that GE is building. All of that is coming off of a data center. So data center are these massive buildings, units, consuming about 30% of world's electricity. So that's where, I'm listing down some of the problem statements as well, what data centers are trying to do. And they look like this. There are these massive shelves, racks, and then in those there are the equipment that goes, there are tons and tons of network cabling that goes, that makes all the connectivity and stuff go, to managing that. So it started from there, infrastructure, you start managing those servers, the servers would go down, like any other equipment, there would be some downtimes, the servers would go down, the network equipment would fail, there would be latency, the storages would fail because they were all back then disk-based storage, they all keep spinning, and anything that is mechanical would generate heat, would break down. To the new world today, and this has all already happened. This has all already happened in the last 10 years, that everything is more or less standardized, completely software controlled. If you have to make a fix, you program it and you make a fix. Even if there is a mechanical or a physical failure, there is a robot arm that you program and it just goes. You don't have to fly in people, you don't have to send engineers on the ground and so on. So that's the disruption that has happened, and it's just been a fascinating, to watch that and to track that and to work in that area. And my intention in the next 20, 25 whatever minutes is so that I give you guys an appreciation of what what the world is opened up to in the infrastructure. It's no longer this sort of red, yellow, green, blue cables. It's a lot more sophisticated, and it's how this community and this fraternity of developers, of AI, ML enthusiasts and practitioners can leverage that. All right. Some numbers, and these are just some numbers, right? There are more and more, much more statistics like this. The first box, there is a trillion-fold change or trillion-fold increase in the compute power that has happened since the time processors came into being. And there is something, and some of you who are computer scientists would know that there is something called Moore's law that started, and companies like Intel and so on. The processing power just keeps increasing, right? You've seen it on your wrists, if you're wearing those smart watches or even Fitbits and so on. You've seen it in the phones that we all carry. If some of you remember the Nokia days, but even when the new smartphones were launched, how many restarts it would take. It would also, and now the processing power that is there in our mobile phones, it's powering mobile banking. We talked about that in the morning, and that has happened because of the underlying ability, not just the hardware. Of course, the hardware has gone smaller and smaller and smaller, and you can pack a lot more per inch, or inch is a very, very big number actually in the hardware space. But it's also about the software programmability of each of those, right? And that has enabled a lot of other disruptions that we all kind of we talk in as if it just happened today, but it has enabled. So I'll talk about some of that. The connected devices, and that's a very interesting piece, right? IoT seems to be the flavor of the quarter, the season, the month, the year. But are IoTs new? Absolutely not, right? Many years back also, whether it was a bar in Delhi or even a juice wala, he would have an RFID device on his refrigerator to check how many bottles were being consumed and things like that. The sensor technology is not new. The sensor technology is absolutely not new. But what is new is the underlying compute power. Now you can crunch data, millions and trillions of record in fraction of time than you would do earlier. The amount of money that it takes to save all that data into storages is a lot cheaper than what it was earlier. And that has opened up, the use cases for IoTs, for whether it is in a simple device or to the most complex. So earlier, people who could afford very, very high-end computing could be perhaps the space labs and all the other labs of all other nature. But today, you have the Raspberry Pi, if you've heard of it, you can buy that for $30 or even less now, and just start programming and use that as an IoT sensor at home and wherever else. So it is just that the amount of the disruption in the infrastructure world has caused all this, what we are talking and experiencing today, to happen. and the appreciation for that somehow seems to be, and I was one of those, right? I was one of those people who was very apprehensive. I'm not a hardware engineer, why should I do this infrastructure job? That sort of a thing. So IoT, as we see today and we want to leverage today, and the numbers that say that is, by 2020 we are looking at over 30 billion connected devices, is a staggering number. And the reason it is possible is because of the underlying compute power, it's underlying storages that go and save all that data and so on. Look at our own usage, right? I mean, there is a statistics in India that says that an average person throws off his or her phone every 12 to 18 months, and the cycle is shrinking. Of course, there are demographics and so on. You cut that you slice that across, and we always buy a faster phone, and a bigger phone, right? Where you want more memory. Thing in my phone, I have about 10,000 pictures stored at any point in time, right? And it just retrieves as fast. I never get to see that that buffer and so on. It is because of the underlying compute power. It is because the storage is still the same, but it's still the 64 GB phone, but the way the storage is being programmed and being leveraged is much faster, right? So say similar things with your personal computers, and we all buy now flash drives and things like that. The cost of, so it's because that cost is coming down and it's more programmable. Flash drive is far more programmable than those spinning hard disks and so on. That's why they are faster. And now they are equivalent, they're no more expensive as well. They're as cheap as the other one. The cloud computing that we all talk about, right? This is another buzzword that everybody wants to get onto the cloud computing and so on. And again, that has been, the disruption in the infrastructure space has enabled that, right? The networks, our networks are a lot more secure now. Our networks are a lot more extensible now. Our networks can be segregated and monitored. And we also talked at great lengths about cybersecurity and so on. So we'll talk about that. The lines are, the point I'm making is that the lines between, this is classic infrastructure, this is classic application, this is classic security and monitoring, and this is classic AI ML are blurring now. One is lending to the other, and you can't, perhaps in my mind, you can't, leverage one if you don't understand and appreciate the other. There are reasons why companies are now hiring full stack developers and not just pure play, say Java developer or pure play, Microsoft stack developer, right? It is because you want them to appreciate the entire life cycle, what goes on, and while they may not be a deployment engineer, but they are coding, but they also understand what's going on, because these lines are blurred. You know how to leverage or maximize the underlying infrastructure, right? The 5 million year statistics is one of my favorites, because I think that's become our way of life, right? I don't know when was the last time I switched on the TV at home to watch my program that comes at 9 o'clock. Now everything is on demand, right? If you miss a coffee with current season, you say, I'll figure it out. When I'm driving to the airport, I'll watch that on demand, right? Sports on demand. Your favorite shows on demand. So the amount of video content that travels through our network, it is just exploding, and each of us are contributing to that, and in a good way, right? And not just us. Earlier, you would notice even for instance, a cab driver or anybody who would just be, either sleeping in the cab, but these days they're all watching and they're all on video and things like that. These days, the default is to do a WhatsApp video call or do a FaceTime call, right? It's no longer, book time and we will call. What does that mean? How's that been made possible? That's been made possible because of the underlying network. The protocols still remain the same. If you've studied those OSI models, the protocol completely remains the same. It's still the same model of the different layers of the network stack. But your network devices are no longer the physical devices. Those are now, the days of those physical specialized devices are gone. The network companies such as Cisco, Junipers, and all of those are also now transforming themselves into software companies, right? Because it's all about how can you program it better and faster. And I think that is where the kick is. Right? Because you all start on a clean slate. These are all dumb machines. Yeah, of course, there is a tweak here and there in the network routers. But the magic sauce is, how can you program it, how can you tune it, and how can you optimize it for the kind of traffic, and can you recognize that, right? I don't know if some of you may have, may recall that, a couple of years back there was this net neutrality debate in India, right? This was all about allowing telcos to channel a certain type of traffic through their faster network. So it's all software programmable, right? So I think those things are exciting. To me, it's as exciting as application programming. The way you are deploying code somewhere and seeing that come to light and life. There is the infrastructure space is also blooming in that sense. It's no longer about, just give me a certain CPU capacity and just give me a certain storage and then I will deploy my code and things like that. Because your fancy applications, your Amazon Primes and your Netflixes, they rely on that. There is a reason why Netflix has the 3 or 4 different flavors for you if you want high quality and so on, because then they will leverage that, and then they'll leverage the speed of your network, and together they'll render the content to you. So it's exciting, and look at the numbers, and they're only growing because our pattern is such, right? I can still say that I was at some point a TV generation, but my children are absolutely not. They don't even care, they don't even bother. It's all on demand for them, and for all of us as well. The data center space is close to heart for me because, when I started and I didn't know what a data center was, to today, where, I have built a tier 4 or helped build a tier 4 data center, moved data centers across the world, enabled them for, complete virtual computing, and, did build a private cloud infrastructure. If you thought, building a house was a pain, imagine a data center, right? Because you have to think really long term, number one. Yes, we'll not talk about the budgets. When somebody decides to build a data center, the budgets are there, right? So let's just park. I'm not going to crib about funding or lack of it. But the technology changing so fast, how do you sitting today make decisions that is going to be at least 20 years, it has to stay on for 20 years and so on, right? And right from the cooling to the power to the utilization, the biggest expense in the data center space is what? It's the power consumption. So you want to optimize, you want to make sure that, while, and the power consumption is definitely by the equipment that is running in there, but it also the air conditioning, because it has to run at an optimum temperature, because otherwise the mechanical parts, have a larger failure rate if you don't. So that's the only theory, or that's the simple theory of why data centers are so cold and you wear jackets when you go inside, right? Because after a certain time, beyond a certain temperature, the mechanical parts would, they are metallic, so they over time that they kind of they wear out. So the data center space is just fabulous, right? I mean, if you thought a data center in Iceland would not be possible, it is possible, and people have gone and put data centers there because there is free cooling and clean air, which is fabulous. So you just put some air filters, and I'm obviously oversimplifying it, but you put air filters, but you don't have to invest in air conditioning, which is your biggest expense. In India, data centers, India is actually in Bangalore, one of the biggest data centers exist in the heart of Bangalore, or which is now the technical heart of Bangalore, as I call it, which is the outer ring road space. And it takes as much power, just that one data center, and it is owned rather by a company who hosts data centers for a lot of other companies. So it's a managed service, a hosted data center, and the amount of electricity that data center alone consumes is consumed by the entire Whitefield plus Mahadevpura area. That's the amount of electricity that data center just consumes. So there is constant engineering going in and constant problem to solve on how to optimize the data center power consumption. Of course, by the equipment, but also the data center design. So data center design is, again, an exciting space. Very, very exciting space on using what kind of materials. How should the layout be? Can you believe that just by changing, a few rack layouts, you can actually optimize a lot of things, just the way you would do it at your home, right? When you just change some of your furniture layouts, you suddenly see there's a lot of space, right? So things like that, again, oversimplified, but there are some technicalities to it. But if you are if there is an element, that interests you, trust me, that's an exciting, super exciting space to explore. The other piece that is in the data center space is or rather the equipment or the environment that goes in is the open compute platform. I don't know how many of you have heard about the open compute platform. So companies such as Facebook, companies such as Google, companies, and Goldman is also part of that. They came together and they said that, while the Intels and the NVIDIAs and the AMDs of the world are making chips, and that is where your infrastructure starts, right? That's your processor, and then you build storage on top of it, you put network on top of it, and so on. How about collaborating with them and telling them that this is the size and this is the way we want it to be tuned, or this is the way we want it to be done for us? Because if it's an investment bank, they want high-speed traffic, right? They don't want processing, they want to optimize the processing ability so that they can do more with less. Similarly, if you're a Facebook and you are the biggest container for photographs across the world, I don't know, I've lost count of how many billion pictures exist, and the millions that get uploaded every day, someday you're going to get out, run out of space. So how, and run out of processing capability and so on. So can we work? So there was a fraternity created called Open OCP, Open Compute Platform. So Google's and these guys, they work directly with the manufacturers, tailor it to their requirements. So that again is an exciting space, right? If you get to give the requirements and design it for that. So net, fabulous stuff happening here. Very exciting space. What am I doing? Yeah, okay. And like I said, there is disruption. All in all, who would have thought, right? Who would have thought that simple boxes can now convert into software powerhouse? If you use an iWatch, you realize that the kind of software powerhouse it is, or even your phone, it's a software powerhouse that is running on that little device, and it's all powered by the underlying infrastructure. What's next? Okay, all this is done and dusted. It's all done, and from being a very boring sort of a topic earlier on, it's now become glamorous. So what's making it cool and sexy now? I think it is this, right? We are now talking hyperscale, because companies are investing in private cloud. Companies are also leveraging public cloud. There are, of course, folks from Microsoft sitting here. They would say that. And companies want to do both, right? We are calling it the hybrid cloud model. So there are hyperscaled data centers. Hyperscaled is essentially that you kind of scale out. You're able to scale in and scale out not just your application. If you're an application programmer, then you would know that the requirements are always that I should be able to scale up and scale down as per the volume or as per the traffic, and that's how your performance of your application is determined. Software-defined infrastructure, I think it's already checked in the box. It's already there. If firms are not doing it, then they're definitely getting onto that bandwagon. Nobody is buying bare metals anymore. I'm sure each of you would know if you're requesting for bare metal environment, then your management would question you, why bare metal? Why can't it go on virtualized stroke cloud, right? So I think we've already gone past that milestone. Hyper-converged infra is a very fascinating space, very fascinating space. And if there is one proud Make in India company, there's a firm called Nutanix. I don't know if you've heard about it. It's truly Make in India, and of course in San Jose. They're pioneers, they're leaders in the hyper-converged space. Hyper-converged, requires, or it's best used if similar workloads are deployed on the same environment. Basically, there is no sophistication in the hardware, it's all software. So it's all just like-to-like boxes, but you can program it. If you say that I want to run my entire Exchange platform for 30, 40, 100, 200,000 people onto, and then you can program it to what Exchange would require to do. Similarly, if there's another type of application, then you can tune that. It's a fascinating space, and I would encourage you to look up more on hyper-converged infrastructure. Operational downtime and bye-bye maintenance windows, right? Which is interesting. Everybody wants to get there, but I'm not too sure how many firms are there. But the aim is to get there. That combined with infrastructure as a service. So Infrastructure as a service means that you are not, again, you're not requesting things in chunk. It's always on, always available, and you should be able to just say, give me 5 more VMs, and it just gets provisioned just the way you would drag and drop. So you think of it as a canvas, and you are able to just drag and drop, saying add more, attach more storage, or demise more storage. And as a dashboard, you are able to see just the way a cloud provider would be able to see things, that how it is being utilized and so on. On top of that, so that forms your base, and on top of that, you create applications which offer platform as a service. So I work for a bank, right? We offer banking platforms to various applications, and they build on top of that. So that platform on a service is able to leverage, or is able to be self-healing, whereas if the platform thinks that I'm going out of memory, or I'm going and that's why incidents happen. So so why do we need maintenance? Okay, let me just talk about that. Is because you want to patch something, you fear something is going to go wrong, and then you want to patch proactively, or something has already gone wrong, there's an incident that has happened and you want to fix it, right? An incident could happen in an infrastructure space, it could happen in an application, with an application, and so on. And then you go and fix your code, or you fix the environment. In that scenario, where in the self-healing world, and a lot of applications are there at this point, where the application itself alerts itself that I'm going to go down now, so these are the things that I need to take actions, and your underlying infrastructure allows you to do that, right? So that stack, if you build infrastructure as a service, software as a service, your application, then you can offer platform as a service. So I think so that's where you see the point that I was making, that the lines are blurring, that my infrastructure stops here, my application starts here, and now the analytics and everything starts on top of that. They are all absolutely blurring. And one thing is just lending to the other, or rather the other thing is it's kind of coexisting and co-creating, if you will. Right? And that's why my belief that infrastructure is as important as building world-class applications. If you can't do one without the other, right? So your underlying infrastructure also needs to be robust, needs to be modern, needs to be completely software controlled. You can't, because if that becomes your weakest link, then whatever fancy app that you built, it's not going to scale, it's not going to deliver its fanciness or to its potential. So that's why I said that so sometimes just going back to my example, that is there a career opportunity? So if you are interested in programming, if you are interested in the big data space, there are data engineering. Data engineering is another very, very underrated space. Everybody is talking AI, ML, building models, deep learning. I think deep learning is another overrated. Everybody wants to do all of that. But nobody talks about the underlying data. Nobody talks about fixing that piece. I know GE has a great problem at hand because there's a large, it's multiples of an MNC, right? GE is, because there are multiple companies, and everybody is generating their data, and then how do you cross leverage that, and so on. But getting the data right is the first space, and data engineering, if you are in the database space, or if you are in the DBA space, the next step could be to take a leap of faith and develop that, and it's a very rewarding, very rewarding career path to my mind. Cybersecurity, we talked at length about some of those sessions, and that's what I'm saying, that it's infrastructure, cybersecurity, application development, they're all kind of intertwined now. Platform engineering, data center analytics, the amount of, if you are in the analytics space, take data center as your use case and see the kind of predictive modeling that you can do there. And that would be really material, really material. There is a lot of money that could be saved. There's a lot of heartaches and heartburns and long nights that could be saved if there is applied predictive modeling in the data center space, right? If things could go down, or your security monitoring and things like that. If you can predict, and that easily predictable, because now you have access to the devices that are running there. Now your equipment is giving you feedback by way of logs and information and so on. So that's fabulous. Software reliability, of course, Google pioneered it, software reliability engineer, and that's exactly what I was just talking about. That how many incidents come in my application. That's the software reliability piece. And it's not just an application thing to control incidents. And how many times we blamed it, oh, the server went down, not my problem. Infrastructure team didn't help and things like that. So again, put together, the software reliability engineering is not just, I will only watch the infra space or I'll only watch the app space. It's going to be across. Cloud engineering, of course, I think that everybody wants to talk about that, and that is the flavor to go to. But how do you tune that? How do you create those cloud managers and then the manager of managers and so on? It's a very fascinating space if you'd like to explore that. So these are all very tech focused, roles, areas to work on. And the last but not the least is the collaboration stack and tools. We undermine the power of collaboration, or actually we don't now, because most companies are investing heavily in collaboration tools, and most of companies are working in an agile mode and so on. It becomes more and more important that we collaborate a lot more. So whether it is sophisticated video conferencing, it takes a lot to build that video conferencing network and video conferencing ecosystem going, or even the other collaboration tools that you may be using, friends from Microsoft, Skype, and so on. But that's a very, very, very interesting space, very interesting space. Lot of computers are now biometric enabled, right, our phones as well, the face IDs and so on. So those kind of spaces as well, if those device engineering and those kind of things excite you. So net, all I'm saying is, from my experience, I had a bias, I had a stereotype, but the bias, if there is any bias or stereotype in your heads, just shake that up. There is a lot of engineering, a lot of programming, a lot of analytics, a lot of opportunities existing in the infrastructure space. It's not just about hardware as I thought it 10 years back. So, and I'm going to be around, happy to chat more, give you more examples. And yeah, I don't now work in infrastructure space, but I'm deeply passionate about it. But thank you so much for your patient listening. Happy to take questions.
Yeah, any questions? Okay.
All right. Yeah. Thank you so much.
Yes.